This Hi, welcome dear students. Regarding the first problem in our screening test, we have given that R is equal to 2, 3, 3, 4 be a relation defined on set of natural numbers. Then find the minimum number of ordered pairs required to be added so that it becomes an equivalence relation, right? Because this is a relation defined on natural numbers that my dear students, first I want to make it reflexive. Okay, if I want to make it reflexive on these ordered pairs, I want to make it reflexive because this is already asked in JE mains. Okay, 2019 or 18, some bit like this. Reflexive. First, I want to make it reflexive on these ordered pairs 2, 3, 3, 4. We should have here 2, comma 2 and 3, comma 3 and 4, comma 4 like this. These ordered pairs are supposed to be included to make it reflexive because we want to make it equivalence relation. We should have to get that it should be reflexive, symmetric and transitive. Now symmetric, right? Symmetric. If I want to make it this as symmetric, 2, 3 is there, I should have 3, comma 2 I should have 3, comma 2 and 3, 4 is there, I should have 4, comma 3 like this, right? 3, 2 and 4, 3 should be there already in it, of course, right? Then it becomes symmetric, of course. 2, 3 is there, 3, 2 is there, 3, 4 is there, 4, 3 is there, and it is reflexive and symmetric now. Next, we have to make it transitive. Okay, transitive means, right, we want to make it transitive. Transitive means what? See, we have to do 2, 3 is there, 3, 3 is there, 2, 3 is there. Okay, 2, 3 is there, 3, 2 is there, 2, 2 is there, 3, 4 is there, 4, 4 is there, 3, 4 is there, right? And 3, 2 is there, 2, 2, 3 is there, 3, 3 is also there like this. Wonderful, right? Next we have here 2, 3 is there, 3, 4 is there. That means 2, 4 should be there. Okay, 2, 2, 3, 3, 4. To make it transitive, we should have 2, 4. 2, 4 is there and 4, 2 also should be there because it should be symmetric like this. Right, now you have all the ordered pairs, I think so, my dear students. You see, okay, then it becomes an equivalence relation. Then the minimum number of ordered pairs which are required to be added, 1, 2, 3, 4, 5, 6, 7. Therefore 7 ordered pairs are to be added such that it becomes an equivalence relation. Option A. Okay, for subdivision A is 7 and B is nothing but these are all the ordered pairs. Those are required to be added to make it as an equivalence relation, right? The second question is using Venn diagrams. You need to verify that number 1. Okay, the A part is A minus B union C. A minus B union C is equal to A minus B intersection A minus C like this, right? If you take the left hand side part here, if you take see, this is what A minus of B union C. We will take 3 sets like this. We will take 3 sets like this. This is A, this is B, this is C. You have here like this. A minus of B union C. From A you have to take out B union C. That means what part you are going to get is this. Okay, from A you need to take out B union C part. This is what we have here, my dear students. A minus of B union C like this, right? Next, the right hand side part, let us see that if we get the same portion of the area, then both are equal like that. Okay, you see, this is what we have here. Now A minus B. Okay, let us have the 3 sets like this. A, B, C like this. A minus B intersection A minus C, we have to prove that. A minus B is this. I am taking with horizontal lines. A minus B, I am taking with the horizontal lines like this. A minus B I have taken with the horizontal lines like this. Next, A minus C I am going to take with the vertical lines. A minus C, right? I am going to take A minus C is nothing but this part, right? I am going to take with the vertical lines like this. Fine. Therefore, now we need the intersection part. Intersection part means what? The gridded portion like this. Intersection means the gridded portion. This is nothing but a minus b intersection a minus c, like this. Right? See, the gridded portion you have got the same thing like this. The gridded portion you got the same thing. This is what you have here. Here also you have got this one, of course, here. Both areas are same. Therefore, what we can say is nothing but this a minus of b union c. The left hand side is equal to the right hand side. Therefore, we got left hand side is equal to the right hand side part. In this way, you will be proving this the first result in the second question. Right. Now, the second part, B part is we need to prove that A minus B intersection C equal to, we should prove that A minus B union A minus C, like this, right? For this, you take the left hand side part here like this, A minus of B intersection C, like this, okay? Left hand side part, if you take, what we are going to have, you see, my dear students, this is what A, this is what B, this is what C, like this. A minus of B intersection C. See, B intersection C part is this. Okay, from A we need to take out that B intersection C part. A minus of B intersection C. This is what B intersection C part, my dear students. You know that. From that we need to, from A we need to take that part. That means you see here, this is what we have here like this. Right, this one. Okay, this is what, okay, we have here A minus of B intersection C part like this. Right, this is shaded like that. Okay, of course, only one portion we have here. Now you take the right hand side part here, of course. If you take the right hand side part, right, we have A minus B union A minus C. This is A, this is B, this is C. We have here like this. Alright, A, B, C. A minus B. Okay, let us write A minus B with horizontal lines like this. A minus B with horizontal lines like this. Right, and A minus C with the vertical lines. We will write A minus C with the vertical lines. A minus C, you know, with the vertical lines we are going to write. Right, this is what A minus C with vertical lines we have written now. Now A minus B union A minus C means these are horizontal and vertical and a gridded portion like this. This is what gridded portion. This is nothing but A minus B union A minus C, like this. A minus B union A minus C. Okay, union means we have to take the elements of A minus B or A minus C or both A minus B intersection A minus C. That both part we have to take. That's why we have got here. Now here what is the area it is representing? Union means this is the area it is representing here like this. And here also the area representing is this only, like nicely this part only we are writing. Therefore these both are equal. Therefore we have got left hand side is equal to the right hand side part. Right, such a beautiful way we will be proving this particular result. The second one also. See the third problem, my dear students, the A part in that, prove that sine 55 degrees minus sine 19 degrees plus sine 53 degrees minus sine 17 degrees equal to, we should prove it as cos 1 degrees. For this what we do is the solution part. Let us take this sin C minus sin D. You know the sin C minus sin D is 2 cos C plus D by 2. Okay, 2 cos C plus D by 2, like this whole thing. 2 cos C plus D by 2 sin C minus D by 2. 55 minus 19 by 2, like this. Right, 2 cos C plus D by 2 sin C minus D by 2. In the same way here also sin C minus sin D, if you apply 2 cos C plus D by 2, that is now 53 plus 17 by 2. 2 cos C plus D by 2 sin C minus D by 2. That is 53 minus 17 by 2. Right? We will get this thing like this. Right? Now this become 2 cos C plus D by 2. That is 55 plus 19. That is 74 by 2. That is 2 cos 37 degrees. And this is 55 minus 19, that is 36 by 2, sin 18 degrees. Plus 2 cos 53 plus 17, that is 70 by 2, that is 35 degrees. And we have here sin 53 minus 17, 36 by 2, sin 18 degrees. What we do is here we take now 2 sin 18 degrees. This common, if we take this as common, what we will get is now cos 37 plus cos 35 degrees. We are going to get like this. Now this is now 2 sin 18 degrees into this is cos C plus cos D, right? Cos C plus cos D means what you will get? 2 cos C plus D by 2. 2 cos C plus D by 2. That means 37 plus 35 by 2. Cos C minus D by 2. 37 minus 35 by 2. Like this we will get. Now this is 2 sine 18 degrees. 2 sine 18 degrees into, right, 37 plus 35 by 2, that you are going to get 72 by 2. That means 2 into cos 36 degrees, like this. Into, this is now cos 37 minus 35 by 2, that is cos 2 by 2 is cos 1 degree, like this. Now you see, my dear students, this is 2 into 2, 4. Sine 18 degrees is root 5 minus 1 by 4, like this. Into, this is cos 36 degrees is root 5 plus 1 by 4 into cos 1 degree, like this, right? This if you simplify, 4 into root 5 minus 1 into root 5 plus 1, that become what? 4. Okay, by 4 into 4, like this, into cos 1 degree, like this. They will cancel and you have got that is equal to cos 1 degree. You have taken nicely the left hand side and you proved the right hand side part in this way beautifully, right? Fine. Now see the third one, B part, what we have here. Okay, they given that if cos x plus cos y is equal to 1 by 3, sin x plus sin y is equal to 1 by 4. You need to find sin x plus y. Okay, we need to find sin x plus y. This is what we require to do. For this, you see, my dear students, what we do is cos x plus cos y is equal to 2 cos c plus d by 2. That means 2 cos x plus y by 2 cos x minus y by 2. That is equal to 1 by 3. Right? And here sin x plus sin y. Right? Let us take this as equation number 1. Now 2 sin c plus d by 2. 2 sin c plus d by 2. Sin c plus sin d. 2 sin c plus d by 2 cos c minus d by 2. That is now x minus y by 2. That is equal to 1 by 4. We call it as equation number 2, like this. Now we let us do what? 2 divided by 1. 2 divided by 1 we will do. If you do 2 divided by 1, then what you will get? 2 sine of x plus y by 2. 2 sine of x plus y by 2 cos of x minus y by 2. This whole thing divided by 2 cos of x plus y by 2 into cos x minus y by 2. That is equal to 1 by 4 by 1 by 3, like this. Now 1 by 4 into 3 by 1, that equal to 3 by 4, like this, right? And here this cancels, this cancels. We have got tan of x plus y by 2 is equal to 3 by 4. Tan of x plus y by 2 equal to 3 by 4. We want to find the sine of x plus y. We know the half angle formula, sine theta is equal to 2 tan theta by 2 by 1 minus tan square theta by 2. By using this formula, 2 tan x plus y by 2, 2 tan x plus y by 2 by 1 plus tan square x plus y by 2. Right? Fine. Once we have got the thing like this, this is now 2 tan of x plus y by 2. 2 into 3 by 4, whole thing divided by 1 plus tan square x plus y by 2. That is nothing but 3 by 4 whole square, like this. Right? Now this is actually 2 into 3, 6 by 4 divided by 1 plus 9 by 16 we have here, like this. Now 6 by 4 divided by, if you take LCM as here 16, 16 plus 9 you have like this, right? 16 plus 9 we have like this. Now this of course we do here now 6 by 4 into 16 by 16 plus 9, 25, like this. 4 1s, so 4 4s. That equal to 24 by 25 we have got. This is the value of sine x plus y. This is equal to sine of x plus y, like this, sine of x plus y. 24 by 25 is the value of sine of x plus y, like this, right? Now see, my dear students, this problem, fourth one, A, 1 plus secant 20, 1 plus secant 40, 1 plus secant 80 degrees equal to cot square 10 degrees we require to prove. How we are going to do? This is, 1 plus secant 20 we can write as 1 plus 1 by cos 20 we can write. Right, into 1 plus 1 by cos 40 degrees also you can write this. 1 plus 1 by cos 80 degrees also we can write the left hand side part. Right, this if you take cos 20 degrees as LCM, now it become right, cos 20 degrees plus 1, right, and here also if you take LCM cos 40 degrees like this, cos 40 degrees you will get cos 40 degrees plus 1 like this, and cos 80 degrees if you take here as this, now this is also cos 80 degrees plus 1 like this. Right, you know 1 plus cos 2 theta, 1 plus cos 2 theta equal to 2 cos square 10 degrees. Now here 2 cos square 10 degrees into this also 2 cos square 20 degrees here, and here also 2 cos square 40 degrees like this, because 1 plus cos 2 theta, theta equal to here 40 degrees divided by, we have here now cos 20 degrees, cos 40 degrees, cos 80 degrees like this. Here 1 cos 20, okay, 1 cos 20 we can cancel, 1 cos 40, 1 cos 40 we can cancel like this. Once after cancellation of that, my dear students, you have here 2 into 2 into 2, 8. We have here now cos square 10 degrees, that I write it as 1 cos 10 degrees, cos 20 degrees, cos 40 degrees I will write, and one more cos 10 degrees I will write here like this. Whole thing divided by, we have here cos 80 degrees like this, cos 80 degrees. This is equal to, you know, cos 10, cos 20, cos 40, cos A, cos 2A, cos 2 square A. That we can write as sine 2 power n plus 1. That means 2 power 2 plus 1, that is 80 degrees. Okay, divided by 2 cube into sine 10 degrees like this, right? Because you know the formula cos A into cos, okay, this is the formula we are using, cos A into cos 2A into cos 2 square A, so on up to cos 2 power n A, that is equal to sine 2 power n plus 1 A by 2 power n plus 1 sine A, using this formula, right? Now we have got nicely this, right, into here denominator we have here cos 80 degrees like this. Very good. Into here we have already here cos 10 is there like this. You see my dear students, sine 80 we can write as cos 10, because sine 90 minus 10, that become cos 10. Therefore 8 into cos 10 into cos 10 degrees, whole thing divided by, here also 8 into sine 10, and the sine cos 80 you can write as cos 90 minus 10, that becomes sine 10 like this. 8 will cancel. Now cos 10 by cos 10, that is nothing but cot square 10 degrees we will get. Such a beautiful way we will be getting. This is equal to the right hand side part, my dear students, like this. Right, fourth A will be completed like this. Now the B part we have find the value of cos 10, cos 20, cos 40, cos 80, cos 160 degrees. Right, my dear student, how we do this part is nothing but, we have already told you that cos A, cos 2A, cos 2 square A like this, cos 2 cube A, so on up to cos 2 power n A. This is equal to sine 2 power n plus 1 A by 2 power n plus 1 into sine A like this, right? This is the formula. Here if you take A equal to 10 degrees, right? Now this become now A equal to 10 degrees means cos A into cos 2A, cos 2 square A, cos 2 cube A, cos 2 power 4A. 2 power 4 is what? 16. 16 into 10, that is 160 degrees. This is what we are having. Therefore this formula is nothing but by using this sine 2 power n plus 1. Here n is equal to 4. Okay, therefore 4 plus 1. 4 plus 1 become what? 5. Sine 2 power 5A by 2 power 5 into sine A like this. And this is of course sine 2 power 5 is what? 32. 32 into 10, that is 320 degrees divided by 32 into sine 10 degrees like this. Right, and we can write this as sine 320 degrees, we can write nicely 360 degrees minus something like 40 we can write. Whole thing divided by 32 into sine 10 degrees like this. Now this is sine 360 minus theta minus sine theta, that is now minus sine 40 degrees by 32 into sine 10 degrees like this. Now this is minus of sine 40, that is sine 2 theta, that is 2 sine, okay, we have just like this, of course we can leave like this, otherwise minus sine 40 by 32 sine 10 degrees like this. We don't have a common angle, otherwise we can further simplify also, we can write like this, right? Further we can simplify this, my dear student, minus sine 40, we can write as sine 40 as sine 2 into 20, that becomes sine 2 theta, minus 2 into sine 20 cos 20 by 32 sine 10 degrees. That is now sine 20, once again we can apply sine 2 theta formula, theta equal to 10 degrees, minus 2 into 2 sine 10 cos 10 into cos 20 by 32 into sine 10 degrees, like. Now 4 1, so 4, right, 4 8 32, sine 10 will cancel. Now we have got minus cos 10 cos 20 by 8 like this, right, my dear students. In this way we will be proving the second part of it, right? Now see, my dear students, we have given that two relations, like S is one and T is another one like this. We need to find the nature of the relations. That means whether it is a right equivalence relation, or is it a partial ordered relation, or is it a reflexive, symmetric, anti-symmetric, transitive. We have to find this. Now for S, let us find first, okay, whether it is a equivalence relation or not, or is it a reflexive or something like this. For S we do this. Okay, first reflexive, let us take a reflexive. Okay, reflexive means what we should have here, x should related to x, okay, but here they are given that x related to y. How they have given x related to y? They given y is equal to x plus 1. This is the relation they have given, where x belongs to 0 to 2. Okay, x belongs to open interval 0 to 2. This is what they have given. X related to x means what we will have, x is equal to x plus 1. Is it true? X equal to x plus 1? It is never true. Therefore, it is not reflexive. Next, symmetric, right? Symmetric. You see, my dear students, symmetric. Okay, symmetric means what? If x related to y, then we should prove that y related to x like this. Okay, x related to y means, you know that, okay, y is equal to x plus 1. By using y equal to x plus 1, can you say that, right? Okay, now y related to x. Y related to x means what you have to say? X equal to y plus 1. By using y equal to x plus 1, can we say that x equal to y plus 1? Never. It cannot be possible. Therefore, it is not symmetric. Number 3, transitive, right? Transitive, right? Transitive means what we have to prove? If x related to y related to z, then we should prove that x related to z like this. X related to y means we know that y is equal to x plus 1. Y related to z means z is equal to y plus 1. Now using these two, we have to prove that z is equal to x plus 1. Is it true? Let us see that now. Z is equal to, you have here like this. Z is equal to y plus 1 you have here like this. Y plus 1. Y means what? X plus 1 plus 1. That is x plus 2 you are getting. But we have to get z equal to x plus 1. Then only z will relate, okay, x will be related to z. But here we don't have, it is not satisfying. Therefore, okay, x is not related to z. Therefore, it is not transitive also. Therefore, it is not an equivalence relation. It is not an equivalence relation. S is not an equivalence relation. Now, we have here, right, what we have, t is equal to x comma y such that x minus y is an integer. That means you take first reflexive. You take first reflexive, right? Reflexive, we want to prove that. That means x should related to x. That means x minus x is an integer we have to prove. Right? X minus x is an integer. X minus x means 0. 0 is an integer. It is true. This is true, Nana, right? It is reflexive. Next, the second one, symmetric. We need to prove symmetric. Symmetric means if x related to y, using that we should prove that y related to x. If x related to y means what? Right? X minus y is an integer. This is an integer like this. Right? If x minus y is an integer, negative of x minus y is also an integer. This is also an integer like this. Right? That means y minus x is an integer. This is also an integer. That means y related to x, right? It is true. Y related to x means y minus x is an integer. That is true, right? Now the third one, transitive. Transitive, what we have to prove? If x related to y, y related to z, then we should prove that x related to z. Here you take x related to y. X related to y means x minus y is an integer. Integer means I am going to take some k, where k belongs to z, like this. Y related to z. Y related to z means y minus z is also another integer. I am going to take that as some k dash. K dash also belongs to z, like this. Now using these two, I should prove that x related to z. Okay, let us take this as equation number 1 and equation number 2. These two, we are going to add them. Okay, if you do 1 plus 2, if you add them, what you are going to have is x minus y plus y minus z is equal to k plus k dash, like this. Minus y plus y will cancel. X minus z is equal to some k double dash. Integer plus integer is an integer. Okay, here k double dash is belongs to integer. That means x minus z is an integer means the thing x is related to z, like this. X related to y, y related to z, then x is related to z. That means it is transitive. Therefore T is an equivalence relation. This is an equivalence relation, right? T is an equivalence relation where S is not an equivalence relation. Not an equivalence. Okay, this is not an equivalence relation, right? This is not an equivalence relation. Like this, we will be doing these problems, my dear students. Thank you very much. The nature means here we have what? T is an equivalence relation and S is not an equivalence relation, right? Fine. Thank you very much.